Alright, today we're going to do a separable differential equation. So it looks like this, and one of the steps I like to do is take 2y and change this y prime into dy dx. It makes it easier to see how it's separable. Alright, so now that we have that, we can write a differential, or not a differential, we can write integrals basically. We can write integrals. So I'm going to move this dx over here, and that's pretty much it. So we have 2y dy, which equals x dx over the square root of x squared minus 16. So the trick for this one, you have to use u substitution for this side of the equation. So I'm going to we have to first take the integral. So I'm going to let u equal x squared minus 16. So I'm going to take the derivative of u with respect to x, which is 2x. I'm going to rewrite that as du over 2x, which equals dx. If we look closely, we could just put dx over here, put u right here, and now we could solve for all of these integrals. So this integral right here is simply add 1 to the exponent, which is 2, and divide by the new exponent, which is 1. So we can rewrite that integral as y squared equals, now we're going to do all the u substitution. So we're going to take the integral x, we said du, well, I'll write that after. Take the square root of u times dx, which is du over 2x, and these x's cancel. So now what we have is y squared equals 1/2 u, I'm just going to rewrite it as this, it's the same thing, I've just moved the exponent upstairs, so it'll be du. And now we add 1 to the exponent, which is 1/2, divide by the new exponent, which is 1. So we get y squared equals u 1/2 plus c. Now we said u was x squared minus 16, so we could plug that back into there. And now we can take the square root. So y of x is simply x squared minus 16, the square root, plus c times this over the square root. It's kind of ugly, but that's your general solution.